Opening and setting the stage. 12,241 nuclear warheads, the largest arsenal in human history. But is it enough to stop a civilization that has mastered interstellar travel? Today, we are going to analyze exactly what happens when humanity's most powerful weapons face technology that could be thousands of years ahead of us. This is not science fiction. This is a data-driven analysis of real military capabilities versus theoretical alien technology, and the results might surprise you. Let's establish our baseline. According to the Stockholm International Peace Research Institute's 2025 report, 9 countries currently possess nuclear weapons. Russia leads with 4,380 warheads, the United States follows with 3,700, and together they control 87% of the world's nuclear arsenal. But here's what most people don't know. Out of those 12,241 total warheads, approximately 2,100 are kept on high operational alert, ready to launch within minutes. These are not museum pieces. These are active weapons of mass destruction, each one capable of leveling an entire city. For our analysis, we're assuming our alien visitors represent a Type 1 to 1.5 civilization on the Kardashev scale, meaning they've mastered planetary energy sources but haven't quite reached stellar-level engineering. This gives us a reasonable technological gap to analyze without entering pure fantasy. Now let's break down humanity's defensive capabilities systematically, starting with our most proven systems. Missile Defense Systems. The Terminal High Altitude Area Defense System, or THAAD, represents our best shot at intercepting incoming threats. And the statistics are genuinely impressive. Lockheed Martin reports a perfect test record, 17 successful intercepts out of 17 attempts. But let's be honest about what these numbers actually mean. These tests were conducted under controlled conditions, against known trajectories, with predetermined timing. Real combat introduces variables that no test can simulate. The Congressional Budget Office notes that while hypersonic weapons travel at Mach 5 to 10, they can perform evasive maneuvers that make interception exponentially more difficult. Russia's Kinzhal missile, which has been used in actual combat in Ukraine, represents exactly this kind of challenge: high speed plus unpredictable flight paths. Here's the critical limitation. THAAD uses hit-to-kill technology. Think of it as trying to hit a bullet with another bullet, except both bullets can change direction. This works against conventional ballistic missiles that follow predictable physics. But against alien technology that might ignore our understanding of inertia and gravity, that's a completely different equation. Nuclear weapons. Let's talk about the elephant in the room: nuclear weapons. Humanity possesses enough nuclear firepower to destroy our own planet several times over. The question is, does that matter against aliens? A single modern thermonuclear weapon releases energy equivalent to 15 million tons of TNT. The largest ever tested, Russia's Tsar Bomba, yielded 50 megatons. But here's what makes nuclear weapons truly strategic. They don't need to hit their target directly. The electromagnetic pulse from a high-altitude nuclear detonation can disable electronics across thousands of square kilometers. This means even if alien vessels have superior shielding against direct impacts, their electronic systems might still be vulnerable to EMP effects. But there's a dark calculation here. Using nuclear weapons means accepting massive collateral damage on Earth. Every nuclear weapon we detonate in our own atmosphere is a victory for any invasion force. They're achieving destruction without firing a shot. The strategic doctrine here becomes mutually assured destruction on an interplanetary scale. We are essentially saying, you can conquer a radioactive wasteland, but you can't conquer a functioning planet. Directed energy weapons and railguns. Now we enter the realm of science fiction becoming science fact. Directed energy weapons. The U.S. Navy has already deployed 30-kilowatt laser systems on destroyers, and the United Kingdom recently achieved its first successful test of the Dragonfire laser against aerial targets. Lasers have one unbeatable advantage. They operate at the speed of light. No travel time, no trajectory calculation, no leading the target. Point, fire, hit, instantaneous. The cost per shot? Less than $10 for a laser compared to millions for a missile. But here's the critical limitation that military planners won't advertise: atmospheric interference. Fog, smoke, dust, rain, anything that scatters light dramatically reduces laser effectiveness. An alien force could potentially neutralize our laser defenses simply by deploying atmospheric obscurance. European researchers are developing electromagnetic railguns that fire projectiles at Mach 6 using pure electrical energy. These weapons could theoretically achieve ranges up to 220 nautical miles, with projectiles that destroy targets through kinetic energy alone. No explosives required. However, after decades of development, the U.S. Navy quietly removed funding for railgun research in 2021. The technical challenges proved insurmountable: barrel wear out after just dozens of shots, and fire rates too slow for effective defense. Alien technology speculation. Now for the sobering reality check. If aliens can achieve interstellar travel, what does their weapons technology look like? Conservative estimates suggest that mastering interstellar travel requires energy manipulation capabilities at least 1,000 times beyond current human technology. We are talking about civilizations that might harness antimatter, where 1 gram releases energy equivalent to 43 kilotons of TNT. Consider this: every UFO sighting that demonstrates impossible maneuvers, instant acceleration, right-angle turns at high speed, hovering without visible propulsion, suggests technology that has solved inertial mass problems. If they can manipulate inertia for their vehicles, what does that mean for their weapons? Theoretical alien advantages include space-time manipulation for defensive shielding, directed energy weapons with power outputs measured in terawatts rather than kilowatts, and artificial superintelligence that can predict and counter human tactical decisions in real time. But here's where human military doctrine offers hope. We have spent 80 years perfecting the art of asymmetric warfare. We know how to fight opponents with superior technology. Asymmetric warfare and human strategy. Asymmetric warfare is humanity's specialty. From Vietnam to Afghanistan, we have learned that technological superiority does not guarantee victory. The core principle: avoid direct confrontation where the enemy is strongest. Exploit their vulnerabilities where they are weakest. Against aliens, this means several strategic approaches. First, exploit Earth's environment, our atmosphere, weather patterns, and terrain features that aliens might not understand as well as we do. Second, leverage our manufacturing capacity. China alone produces over 1,000 military drones annually. In wartime production, we could potentially deploy swarms of millions of inexpensive drones. Death by 1,000 cuts, rather than attempting to match their advanced individual units. Third, cyber warfare capabilities. If aliens rely on digital communication and control systems, our 30 years of cyber warfare development becomes a force multiplier. We might not be able to match their physics, but we might hack their software. The Vietnamese defeated American forces not through superior firepower, but through patience, local knowledge, and willingness to accept casualties that conventional armies cannot sustain. This mindset becomes our template for interplanetary resistance. Global military cooperation. Here's where the alien threat creates humanity's greatest opportunity: forced unity. NATO's 32 member states, representing 55% of global military spending, would need to expand beyond Earth-based conflicts. The United States Space Force is already developing international partnership strategies with allies across the globe. Countries like Australia, Japan, the United Kingdom, France, and Germany are rapidly expanding their space-based military capabilities specifically for coalition operations. This cooperation includes shared early warning systems using over 800 satellites currently in orbit, coordinated cyber defense capabilities, and most importantly, shared industrial production for rapid wartime manufacturing. The precedent exists. During World War II, Allied cooperation transformed individual national capabilities into a force multiplier that exceeded the sum of its parts. An alien threat would necessitate this same cooperation, but on a planetary scale. The harsh mathematics of survival. Let's crunch the actual numbers. Humanity's combined military forces include 3.5 million active personnel across NATO alone. Our nuclear arsenal represents approximately 500,000 kilotons of total yield, enough destructive power to sterilize continents. But against interstellar technology, our advantages become massive numerical superiority in personnel and equipment, 80 years of combined modern warfare experience, complete environmental knowledge of the battlefield, and most critically, nothing left to lose. The alien calculation becomes, is conquering a devastated Earth worth the cost of a prolonged resistance campaign that could last decades? Conclusion. So, can humanity's weapons defeat aliens? The honest answer is probably not in direct confrontation. Our best weapons, nuclear, laser, kinetic, represent 1940s to 2020s technology. Theirs potentially represents 3020s technology. But warfare is not just about weapons. It is about will, adaptation, and the willingness to pay any price for survival. Humanity's track record suggests we excel at exactly these qualities. Our greatest weapons are not our missiles or lasers. They are our capacity for cooperation under existential threat, our industrial manufacturing capability, and our proven expertise in asymmetric warfare tactics. The question is not whether we can match their technology. The question is whether we can make victory cost more than it is worth. What do you think? Are there human weapons I missed that could level the playing field? Share your analysis. And if you want to see part 2, where we explore the global coalition strategy and cyber warfare tactics, stay tuned. Because when humanity's survival is at stake, we find ways to win.